In Mathematica, when Mathematica recognizes the syntax of, let's say, a function you wrote, it is highlighted as black. And then inside of it, you can just have whatever function you want and it will do its thing. In our case, it will expand it. But if you had a typo, just like that, and try to do the same thing of expanding x plus 1 squared, you would get the same thing back. That is, it won't do anything. And that is the default behavior. As you can see, the name is highlighted blue. And the reason it is highlighted blue is that Mathematica does not know what it is and it treats it as undefined, just like the X we have over there. Another thing syntax highlight can tell you is if you don't have enough of arguments, in which case it will add this small arrow of color red, and if that happens, you just have to add the additional arguments it is asking for, and you will get this beautiful syntax or whatever you have. Now, there is another example where perhaps we have too many arguments. And in case of this range function that goes from 1 to 10 with a step of 1, if we specify an additional argument, it becomes red because it's not supposed to be there and you have to delete it. Unbalanced equations. What if you have an equation, you wrote it, and now you did not close it? That is, it is unbalanced now. In this case scenario, all expand does, all the Wolfram Mathematica does is that it highlights the other part as purple. All you have to do is complete it, and it will work as expected. We can also look under the hood of how Mathematica sees things. For example, we can say full form, in which case we just specify, let's say, AB plus CD, and it will give us this expression. This is the way Mathematica sees it. Another expression, another form, that might be more useful and perhaps more beautiful is AB plus CD tree form, plus times times, and we get this graph view of the equation we gave it. By no means this is a changing, altering transformation of any kind. That is just a transformation, a form in which we output things. For instance, a similar thing can happen with this vector. Right now it is just a vector. But what if we pipe it into matrix form? In that case, the only thing that would change is that the array would be displayed in matrix form, in a beautiful matrix form. And that is the only reason. Working with units. How would you work with units in Mathematica? To work with units in Mathematica, all we have to do is use this quantity. In which case, the first thing specifies what you want, the amount of it. Then the second argument specifies what kind of units you wanted to have. For instance, in this case, we are adding 10 feet to 5 meters, and it gives us this number, which we can afterwards convert with a unit convert. And we take the last output, and then we convert it to meters. And this gives us an exact number, which we can convert to a numerical representation, which will give us 8 meters. Now, it can work with days as well. That is, you can say 7 days. And I'd like to add, let's say, 100 seconds to these 7 days. Well, in this case, you get what you get. It does add it. Another thing, the last example I want to demonstrate is what would happen if we add 1000 years to the current day and try to determine what day of the week it will be in 1000 years. It's very simple. We add the today's date with this function date plus, and we add 1000 years to it, that is 1000 years. And then we feed this whole thing into day name, and it gives us Saturday. We can also see what day of the week it will be in 1 million years, and it's going to be Wednesday.